All right, today we're stepping into one of the highest stakes environments imaginable, the operating room. This is a place where a single mistake can change everything. We're going to explore a fascinating new idea. What if AI could act as a surgeon's copilot, a real-time guide, kind of like a GPS during a complex procedure? Let's dive in. So, the whole mission here really boils down to this one critical question. What if an AI could step in and help prevent a surgeon's absolute worst nightmare? And we're not talking about just any little slip up. We're talking about the kind of mistake that can happen even during a supposedly routine operation, but with totally devastating consequences for a patient. And trust me, this is not some niche problem. We're talking about one of the most common surgeries on the planet, gallbladder removal. Over 1.2 million of these are performed globally every single year. So you can imagine even a tiny improvement in safety and efficiency could have a massive, massive impact. So let's really get into the challenge here. Because you'd think, with a procedure this common, we'd have it down to a perfect science, right? Well, it turns out there are these hidden risks that have been incredibly tough to solve, both for human surgeons and for the AI developers trying to help them. Okay, so the fancy medical name for this surgery is a laparoscopic cholecystectomy. Basically, it's minimally invasive, which is great. Surgeons use a tiny camera and some very specialized tools to go in and remove the gallbladder. But here's the catch. The surgeon's entire view of what they're doing is on a video screen. And that one little detail introduces a whole new set of challenges. Yeah, that limited view leads to three really big problems. First, there's a serious risk of what they call anatomical recognition errors. That's when a surgeon might misidentify a critical blood vessel or duct, and that can be catastrophic. Second, there's a really long learning curve for new surgeons to get good at this. And finally, here's a huge one for AI. The crazy high cost of getting experts to manually label surgical videos to train an AI in the first place. It's a massive bottleneck. So, to try and tackle all three of these problems at once, a team of researchers developed a pretty amazing new AI system. They call it LC YOLO Match, and it's designed from the ground up to be a true surgical copilot. Now, the real brilliance of this system is that it's a two-part solution. It's not just one thing. First, they gave it a better eye, basically an AI model that can see and understand what's happening on that video screen with way more accuracy. And second, they gave it a smarter brain, a whole new way of learning that gets around that expensive data problem. Let's start with the eye. So, how exactly do you upgrade an AI's vision for something as complex and messy as a live surgery? Well, the researchers essentially took a standard, off-the-shelf AI vision model and totally supercharged it. Their new model, this LC YOLO, has something called enhanced multi-scale feature extraction. In simple terms, it's just much better at seeing both the big picture and the tiny, critical details all at the same time. Then, it has a better way of fusing all that information together, giving it a much more complete and more accurate understanding of the surgical scene. Okay, so the AI has a better eye. That's part one. Now for part two, which is maybe the most clever piece of this whole puzzle, building a smarter brain that doesn't cost a fortune to train. And you really can't overstate how big a hurdle this is. To train a medical AI, you need tons of labeled data. But getting a professional surgeon, a highly paid expert, to sit down and manually trace every little detail in a single frame of video, well, that can take hours. This one problem has seriously slowed down progress for the entire field. So their new method is just genius. It's this elegant cyclical process. First, they start small, training the AI on just a few hundred images that were perfectly labeled by hand. Then, and here's the magic, they use that partially trained AI to make educated guesses on thousands of unlabeled images. It creates what they call pseudolabels. But of course, you can't trust all of them, so the system has a filter that only keeps the guesses the AI is most confident about. And finally, it takes those new, high-quality pseudolabels, adds them to the original training data, and retrains itself. With every single cycle, it gets smarter and smarter, essentially teaching itself from a giant pool of raw data. So, does it actually work? This combination of a better eye and a smarter brain, did it pay off? Well, let's just say the results are pretty impressive. Okay, get this. The baseline AI model, the one without all the upgrades, it scored an accuracy of about 55.6%. Not bad, but not great for surgery. But LC YOLO Match, with its fancy new architecture and that clever self-learning method, it jumped all the way up to 70%.
That is a massive leap in performance, a real breakthrough.
And listen, that 14-point jump isn't just some abstract number on a chart. It translates directly to patient safety. It means the system is far, far more reliable at identifying those absolutely critical structures, like the cystic duct and the cystic artery, the very things that help prevent those dangerous recognition errors we talked about.
I mean, don't just take my word for it. The researchers themselves concluded that this technology can, and I'm quoting here, significantly enhance assistance in laparoscopic procedures while effectively reducing the incidence of complications. That is a powerful, powerful statement about the real-world potential of this AI copilot. And all this brings us to one final, really provocative thought. As this kind of technology gets more accurate and more accessible, you have to ask, are we looking at the future of surgery? Could an AI copilot, this digital GPS for surgeons, one day become the absolute standard of care in every single operating room worldwide?